In this video, we will make a cable for connecting a quadrature encoder to a brushless motor controller, and run a servo motor in direct drive mode. To make the cable, we will use a cable assembly kit that can be purchased from the internet store. Alternatively, the components for the cable can be bought in other places. The part numbers are given in the controller's datasheet. The cable assembly kit consists of a connector and a set of wires with pre-crimped socket blades. If you have a crimper tool, you can also attach the socket blades to wires by yourself. Let's open a datasheet document that comes with the brushless motor controller. Note that each connector has its first pin clearly marked with a 1 sign. Conventionally, the numbering of pins is done in such a way that there are rows of odd-numbered and even-numbered pins. The quadrature encoder's electrical interface has 5 wires in total. Positions of the pins of each of the wires are given in the table. The socket blades need to be pushed into the connector until you feel a click. The blades lock into the connector's sockets. Optionally, primarily for cosmetic reasons, you may want to add a heat shrink tubing to your cable. The brushless motor controllers come in 2 distinct forms, a circular and a rectangular one. Both models are identical in terms of capabilities, features, firmware, and external electrical connectors. The connector has a locking mechanism that keeps it in place. I soldered a mating connector to the other side of the cable, a connector that my brushless motor needs. Note that your motor will likely require a different connector, or no connector at all. It is always a good idea to test an end-to-end integrity of the cable and its connectors. Let's buzz the wires using a multimeter. The cable is ready. The brushless motor controllers feature a direct drive mode of operation. In direct drive mode, the servo controller directly positions magnetic fields inside the brushless motor, and achieves the highest possible precision of positioning accuracy. This mode is used with electric drives that do not have a gearbox. Typical applications are those where use of a gearbox is avoided to minimize backlash-related issues that affect positioning accuracy. A brushless motor operated in a direct drive mode is much better than a more traditional stepper motor. Thank you for watching. Please subscribe to our YouTube, Telegram, or Twitter channels. See you in the next video.